At this exact millisecond, inside your engine, two ultra-precise steel camshafts and a heavy crankshaft are spinning thousands of times per minute in absolute, perfect synchronization. The distance between an intake valve opening completely and a heavy forged piston slapping into it at top dead center is less than the thickness of a fingernail. The only thing preventing your engine from violently smashing itself into a pile of twisted aluminum and bent valves is a thin strand of reinforced rubber or a flexible steel chain. If that component snaps, skips a single tooth, or loses tension while you are cruising on the highway, your engine doesn't just stop running. It destroys itself internally in less than 1/10 of a second, leaving you with a $4,000 bill for a completely brand new engine. Welcome back. Today, we are settling the most toxic, misunderstood debate in automotive mechanics: timing belt versus timing chain. Which one actually fails first? Which one is a silent ticking time bomb sitting inside your engine bay? And why are modern car manufacturers secretly selling you timing systems designed to disintegrate right after your factory warranty expires? If you think timing chains last forever, or if you believe rubber belts are completely obsolete cheap junk, you are falling directly into a multi-million-dollar repair trap. By the end of this video, you will know the exact microscopic failure points of both systems, the deadly maintenance lie that auto brands hide in your owner's manual, and precisely which system you should look for before buying your next car. To understand why these two components fail so catastrophically, we first have to address the brutal reality of engine geometry, interference versus non-interference designs. In an older or non-interference engine, if your timing belt snaps, the camshaft stops turning, the valves freeze in place, and the pistons simply move up and down freely without touching them. You pull over, get towed to a shop, slip a $50 belt on, and drive away. But almost every modern car on the road today uses a high-compression, high-efficiency interference engine. To squeeze maximum horsepower and fuel economy out of smaller displacement engines, engineers push the intake and exhaust valves deeper into the combustion chamber. In an interference engine, the physical path of the valve and the physical path of the piston cross the exact same spatial zone at different times. The timing belt or chain is the absolute dictator, ensuring they never occupy that space together. The second that belt snaps or that chain stretches, a piston moving upward at 3,000 RPM violently slams into an open valve at supersonic speed. It punches through the valve, snaps the camshaft, shatters the valve guides, cracks the cylinder head, and gouges deep scars into the cylinder wall. Your engine is instantly transformed into scrap metal. So let us start with the older, most notorious suspect, the dry rubber timing belt. Introduced decades ago to replace noisy gear drives, a timing belt is a continuous loop of high-strength synthetic rubber, heavily reinforced with internal fiberglass or Kevlar tensile cords, featuring molded teeth that mesh directly with the sprockets on the crank and camshafts. Why did automakers embrace rubber belts if they knew rubber degrades over time? Because rubber belts are exceptionally light, dirt cheap to manufacture, highly efficient due to low rotational mass, and operating in near-total silence. But rubber has a fundamentally unavoidable physical limitation: environmental oxidation and thermal fatigue. Every single time you start your engine, the timing belt is subjected to brutal heat cycles ranging from sub-zero winter temperatures to over 200 degrees Fahrenheit under the hood. As time passes, the synthetic rubber dry rots, hardens, and loses its flexibility. The internal Kevlar cords undergo constant tensile stress, stretching slightly every time you stomp on the accelerator pedal. But here is the terrifying part about a dry timing belt: it almost never gives you an audible warning before it fails. It does not squeal, it does not rattle, and it does not throw a check engine light. It operates completely silent right up until the exact microsecond the structural rubber teeth strip off or the internal Kevlar cords snap. 1 second you are cruising comfortably at 60 miles per hour listening to music. The next second, Your dashboard lights up like a Christmas tree, your power steering dies, and your engine mechanicals turn into a blender full of metal shrapnel. This silent destruction is why manufacturers strictly enforce the famous 60,000 to 100,000 mile replacement interval. But here is the first hidden mechanism that almost every vehicle owner overlooks. The timing belt itself is rarely the component that fails first. Inside your timing cover sits an entire support ecosystem of tensioner pulleys, idler bearings, and in many engines, the water pump itself. The timing belt wraps tightly around these smooth steel pulleys, spinning their internal ball bearings millions of times. Over time, the factory grease inside those small idler bearings dries up from extreme engine heat. The bearing begins to overheat, seize, or wobble. The moment an idler pulley seizes, it acts like a high-speed friction brake against the back of the rubber belt. Within 30 seconds of continuous sliding friction, the rubber melts through, snaps, and your engine suffers total destruction. Alternatively, if the mechanical water pump driven by the timing belt begins leaking coolant onto the belt face, that glycol chemical compound aggressively dissolves the synthetic rubber compound, causing the molded teeth to shear off completely. Replacing just the rubber belt without replacing the tensioner, idlers, and water pump is mechanical suicide. Because drivers grew tired of paying $1,000 every 6 years to replace rubber timing belts, auto manufacturers pivoted heavily back to the heavy-duty option, the steel timing chain. Marketing teams love to advertise timing chains as lifetime components. They promise buyers that a steel chain will outlast the vehicle itself, eliminating expensive routine maintenance forever. And on paper, it makes perfect physical sense. Steel does not dry rot like rubber. Steel does not snap instantly under normal tensile loads. A thick, multi-link steel roller chain looks indestructible compared to a thin strip of Kevlar-reinforced rubber. So why are automotive repair shops overflowing with modern vehicles suffering from jumped timing, stretched chains, and destroyed engines at just 80,000 miles? Because the promise of the lifetime timing chain is one of the most destructive marketing lies in modern automotive history. A timing chain does not operate in a dry, protected environment like a rubber belt. It operates directly inside the hot, pressurized oil environment of your engine. It relies entirely on engine oil for two critical functions: constant mechanical lubrication and hydraulic tensioning. While a rubber belt uses mechanical spring tensioners, a modern timing chain uses an intricate hydraulic tensioner powered directly by your engine's oil pressure, forcing plastic guide arms against the chain to keep it bone tight. Here is where the fatal engineering flaw lies. Steel timing chains do not snap like rubber belts. Instead, they undergo a process called pin-end bushing wear, commonly referred to as chain stretch. A timing chain is made up of hundreds of tiny steel pins, plates, and rollers. Every time engine oil becomes contaminated with microscopic carbon soot, unburnt fuel, or moisture from short city trips, that dirty oil turns into a microscopic grinding paste. This abrasive sludge grates away microlayers of steel inside the hundreds of individual pin joints along the chain. When every single pin joint loses just 1,000th of a millimeter of steel due to abrasive wear, the cumulative length of the entire chain increases by several millimeters. This is chain stretch. The chain is not physically lengthening like an elastic band. Its joint tolerances are simply wearing out. As the chain stretches, the hydraulic tensioner has to extend further and further outward to take up the slack. Eventually, the tensioner reaches its absolute maximum physical limit. At that point, the loose steel chain begins violently whipping inside the timing cover, slapping against the plastic timing chain guides. These plastic guide arms, made of cheap nylon compounds, shatter into sharp, brittle pieces under the continuous metallic hammering. Those plastic fragments drop straight down into the oil pan, clogging the oil pickup tube and starving the entire engine of oil pressure. Even worse, On a cold morning startup before hydraulic oil pressure fully builds up, that loose, stretched chain will literally jump teeth on the camshaft sprockets. The engine's variable valve timing sensors instantly detect that the camshaft position does not match the crankshaft position, triggering a heavy check engine light and placing the car into limp mode. If you ignore that warning signal, the very next time you accelerate hard, the chain skips 3 teeth, the valves hit the pistons, and your lifetime timing chain engine is completely dead. Now let us throw fuel on the fire and discuss the absolute worst, most catastrophic engineering disaster on the modern market: the wet timing belt, also known as the belt-in-oil system. In a desperate attempt to combine the low friction and silent operation of a rubber belt with the internal space saving of a chain drive, manufacturers like Ford with their EcoBoost and Peugeot with their PureTech engines designed rubber timing belts that run directly immersed inside the engine oil crankcase. This design has turned out to be an absolute mechanical nightmare. The hot engine oil, combined with unburnt fuel dilution from direct injection systems, chemically attacks the rubber belt compound. The rubber softens, degrades, and literally sheds microscopic rubber fibers directly into the engine oil supply. These floating rubber particles travel straight down to the oil pump strainer, completely choking off oil flow to the top of the engine. The result: total engine seizure from oil starvation, combined with a snapped timing belt, often happening well under 50,000 miles. The wet belt system is objectively the absolute worst, highest failing timing design ever put into production. So let us answer the ultimate question once and for all. Which one actually fails first, and which system is truly superior for your wallet and your car's survival? If we look purely at unmaintained, neglected vehicles where the owner changes the oil late and ignores service intervals, the timing chain will actually fail first or cause massive catastrophic damage much earlier than expected. A timing chain driven on dirty, low-quality or low-level engine oil will suffer severe pin wear, shred its plastic guides, jump timing, and ruin the engine in as little as 60,000 miles. The steel chain is completely dependent on immaculate oil quality. However, if you are a diligent owner who performs frequent oil changes using high-grade full synthetic oil, a timing chain will comfortably outlast a rubber timing belt every single time. Under proper maintenance, a quality steel chain will easily run for 200,000 miles or more with zero major interventions, whereas a dry rubber belt has an absolute hard biological clock. No matter how perfectly you maintain your car, a dry rubber timing belt will dry rot and degrade over 6 to 8 years due to simple atmospheric chemistry, forcing you to pay a costly replacement fee regardless of mileage. Here is your definitive survival guide based on mechanical reality. If your vehicle has a dry rubber timing belt, you must respect the manufacturer's time and mileage limit religiously. Replace the belt every 60 to 90,000 miles or every 7 years, whichever comes first. And never cut corners. Always replace the water pump, tensioner, and idler pulleys at the exact same time. Paying $800 for preventative belt maintenance is infinitely better than paying $5,000 for a new engine block. If your vehicle has a steel timing chain, never believe the lifetime fluid or extended oil drain interval hype. Change your engine oil every 5,000 miles using premium synthetic oil to prevent microscopic carbon buildup from eating away at the chain's pin joints. Listen carefully during cold morning starts. If you hear a sharp metallic rattling sound for 2 seconds when the engine fires up, your hydraulic tensioner or plastic guides are failing, and your chain is loose. Get it inspected immediately before it jumps teeth. And finally, if you are shopping for a new or used car, inspect under the hood carefully. Avoid first-generation wet belt engines entirely unless you want to live under the constant shadow of rubber breakdown and oil starvation. Choose a timing chain if you want long-term durability and are willing to maintain your oil religiously. Choose a dry timing belt if you don't mind budgeting for a routine belt service every few years in exchange for absolute peace of mind while driving. Understand the engineering compromises inside your engine cover, respect the service limits, and you will never have to watch your engine destroy itself on the side of the highway.